Good evening, all of you. To the last session of IAMAI's first edition of Digital Transformation Summit, we have now a panel discussion on a very interesting topic of 3D printing, robotics, and smart manufacturing, what holds the future. For this session, we have with us our moderator, Mr. Sarajit, Chief Business and Transformation and Digital Solutions, Tata Steel. Now the panelists, Mr. Vikas, Sawhney, Vice President Engineering, Bajaj Auto, Mr. Aiyappan Ramamurthi, Technical Director, India Siemens Industry Software, Mr. Saroop, Director, Adroitec Engineering Solutions, Mr. Guruprasad Kuppu, Director and Mentor Leadership Team, Imaginarium, India, Mr. Ankur Goyal, Associate Director, Industrial Sector, Global Business Services, IBM, and India and South Asia. Welcome to all of you. Dear delegates, please keep posting your questions in the chat box. The panel may address a few in the end. Over to you, Mr. Jha.
Thank you so much. Very good afternoon to everyone. And it's there. Whoever has joined us, thank you so much for joining us. I think we'll just take a format where each of the panelists will speak for a few minutes. Then we'll have some question and answers. Please feel free to post your questions there. As all of you are aware, the post-industrial revolution is redefining manufacturing, supply chains, and a society of the future. Embracing sustainability, embedding digital, and creating a more equitable society is today an imperative. The technologies to achieve the same have evolved at a rapid pace and drive disruption as they evolve and collide with each other, creating a combinatorial vortex. So just to give you an example, how they feed off and into each other, analytics and big data would not happen without the cloud. Cloud would not be possible without ubiquitous connectivity. Social would not be possible without mobility, which in turn generates and feeds data for advanced analytics models, and so on and so forth. The action now is shifting towards the industrial space where data, cloud, and edge computing, and of course AI, are driving the next revolution. The World Economic Forum has 69 lighthouse identity sites in manufacturing, which embody the practices of 4IR technologies. You can check this out. Tata Steel, of course, is my company, but it's also the proud possessor of two of those three sites in India. We have a site in Jamshedpur and a Kalinganagar, which are lighthouse identities. The critical question in everyone's mind is how robotics and 3D printing, the two dark horses, which always seem to be promises moving into an ever-distant future, will evolve within the smart manufacturing and bring in the next level of disruption in productivity, capability, mass customization, and sustainability. We have an excellent panel today, bringing in over 100 plus years of experience across providers, practitioners, entrepreneurs, and tech gurus who will shed light on the topic. In the next 45 minutes, we will figure out whether the holy trinity of CNC machines, robotics, and 3D printing will be the holy grail of smart manufacturing. What are the barriers and challenges to adopting the technologies? What can we learn from the leaders in this area? Is mass customization finally within reach, or is it still a distant dream? What does cobots hold for the future? And many more exciting ideas that you can take as a playbook to your respective companies and areas of work. Without much ado, let's dive in. And I would call upon Vikas to make his opening comments, and then we would progress sequentially. Over to you, Vikas.
Thank you, Mr. Jha. Good afternoon, everybody. I'm Vikas Sawhney, working as Vice President Engineering at Bajaj Auto. I'm also heading the Robotics division of Bajaj. And so therefore, I'll be talking more on robotics, how it is going to become a driving force, especially for the automotive and manufacturing sectors in the coming times. Basically, I believe, which is pretty much true, is that the technology is more or less, or adoption of technology is actually driven by the changing market scenarios. So if we just see in the automotives, there was a time when the automotive, especially like scooters and cars in India, they were just basically mass production. There were very few players. It was more of a monopoly. If we see today, there is a huge global reach. International players are coming in. There are more local players. And above and all, the customers are becoming more and more discerning. So all this change in the technology has led to adoption of a lot of things. So I'll just make a basic base why robotics are going to become so important. Actually already have become important. All these changes, I'll talk about three major impacts. One on the product, one on operations, and one on the cost structure. Now let's start with the product. If we see about a decade or 2 decades back, in the product, we always talk about quality, but the importance of aesthetics in a product was never so much of a focus, especially in the Indian and the domestic markets. So, for example, let me say if I'm doing a frame or a chassis of a motorcycle, and I'm talking about the kind of weld beads which are there, which are visible in any kind of a motorcycle. About maybe a decade back, uh, the customers didn't really care. They wouldn't be so much worried about aesthetics. Like it was just a one point to another point of a means. But today it's a status symbol. Today it's a pride to own a bike, and the customers do not want anything which looks shabby. And now those kind of aesthetics to be maintained, to have consistency in those weld beads, that is no more possible with manual kind of a work, because that consistency can be given only by robots. And hence we see that it is the market which is driving a lot of needs. So one of the needs is that this is being happening. The robotics has taken over aesthetic parts, be it welding, be it painting, and so on. So this is one example of a product. So let me take a second example of operations. So in operations, what has become very important now is the flexibility. So the reason being that now the volumes which we produce for any kind of a model are becoming lesser and lesser, because we have now smaller batch productions and much higher volumes, much higher products or the models to be launched, which was not there earlier. So this leads to a need for flexibility in operations. So people talked about SMAD, single minute exchange of dies, which was once upon a time thought to be very enamoring. But now the concept has changed to NTED, which is no touch exchange of dice. So it is like on the fly. So that kind of flexibility is again being provided by a lot of automations, robotics, IoT, and that is where the adoption of IoT and robotics and the interplay is playing a major role in the operations. So the last thing which I'll talk about, the major impact, is on the cost structure. So like typically in automotive in India has huge amount of seasonality when it comes to sales. So like if it's Diwali, so let's say that I have a base sale of 100. In Diwali, I would be selling something like 120, 130. And then there are months where people do not want to buy because of religious reasons or anything, and the sales drop to 80. Now, here the law of averages does not really work. If I have a capacity of 100, then I can't meet a market demand during Diwali. I lose my market share. And if I have a higher capacity, then I'm underutilizing my assets most of the year and only utilizing it probably during Diwali. So here is again where the robotics comes into picture. If I challenge the lunch time, I challenge the break time, I straight away get a 13% increase in production capacities. And I don't have to now deploy manpower for 120. So there is a huge, so this leads me to a cost structure which is actually more variable, because I don't have to keep that kind of a manpower. So like robotics is undoubtedly the future of manufacturing. Of course, it will be leveraged by IoT, by artificial intelligence as artificial intelligence matures more. And the interplay of these three is what is actually going to, I believe, to be the future of manufacturing. Over to you, Mr. Jha. So that's my take on.
Thank you so much. To kind of make a quick comment on that. We believe that whatever is 4D, dumb, dirty, dear, and dangerous, will go to robots and AI, and whatever is 4C, which is critical thinking, care, curiosity, and collaboration, is what will stay with the humans. So maybe that has got some insights for the future of work. But thank you so much for those comments. Whoever would like to go next?
I think I'll go.
Sure.
This is Dr. Guruprasad Rao. I'm the director and mentor at India's leading 3D printing company, Imaginarium India Private Limited, Mumbai. I think we have been trying to disrupt various developments in the country for last a decade, more than a decade, in this area of 3D printing. I would like to call it as a digital fabrication, because the term manufacturing is about making millions. And 3D printing is something which is capable of doing quickly small batch quantities, and even an economic order quantity of one, unity can be addressed. Well, I think when we talk of the interplay between 3D printers and robots, which is the focus of today's panel discussion, I see there are three major opportunities for 3D printers and robots to have. One is, I see definitely slow and steady replacement of 3D printers to robot, which is going to do the same thing. So 3D printers, many times I call them as a CNC or a robot, which kind of de-skills the hand making of artifacts. The hand making of artifacts have been difficult. You needed a skilled artisan to make it. Today, it is all digital thing which can be converted into that, So, and increasingly, the XY table is getting replaced by the robots now, okay, to have better dexterity of positioning. And that way, I see robot as a truly out-of-the-box 3D printer. Because, you take a KUKA robot, a APB robot, or something like that, they have, once you have a print head in their end, they instantly become converted to a 3D printer. So I see there is a trend which is going to move towards, you will have robots for doing many things and also to do 3D in future. So it's going to become a kind of a additional thing, we are fond of that, 2-in-1, 3-in-1, multi-in-1 kind of thing. And the other important thing I see is 3D printing and robot as a partners. There are a lot of, especially in a pandemic situation now, non-contact technologies are very important, wherein I don't have to, when I do a medical product, it need not be handled by humans. So non-contact technology. So robots can come, they can probably help retain or maintain the sterility of the process, of cleaning or post-processing, etc. In fact, 3D systems have come out with a technology called Figure 4, and additive industry has come out with a kind of a bay, which whole system looks like a container, where you have an input bay and an output bay. In between, what happens is a black box where you have a 3D printer, a CNC machine, a robot, all inside, and it can be reached only with an IoT device from outside, from long distance. One can monitor, condition monitor, even look at the various parameters. It is possible to even do quality inspection, in such a thing. So I see a kind of a collaboration between 3D printers and 3D robots is another. Then you have one more area which is very important. 3D printers are becoming a part of robots in the other side of it. That is, increasingly 3D, the robots are becoming very specific, and when you are building them, lot of things need to be customized. And 3D printer being a kind of agile manufacturing option enables you to make these things quickly. For example, a special robot which has got to grasp something, pick and place, it has to do justice to that product. So the end actuator every time has to be redone for a product line. And if the products are changing themselves, with life cycles coming down now to less than 1 year for many products, so people are looking at this agile manufacturing, that is 3D printing, to make the end actuators, which are hard, which are soft, which can be easily adapted. It can be printed on demand. These are the three aspects, which are very important, which are coming, that is 3D printer becoming a robot, or robots are becoming 3D printers, and partnership between 3D printers and robots, and how robots are getting enabled by 3D printers by means of various, you have so-called actuators, which are custom made. I also see there is a great synergy of India having such a large CNC kind of capacity in the country. People shifting to 3D printers or robots could be hard because it is a capex which they have to change, lines they have to change. But I see the G codes, M codes, which are required for for CNC, is also useful to your 3D printers, where we use mostly G codes, and even robots have their own codes. So I see there is a holy trinity that's possible between these, and people are increasingly trying to see if I can have a retrofit of a CNC, a CNC machine behaving like a hybrid, for example. Hybrid manufacturing brings the promise of having a 3D printer and a CNC machine working in the same place, where a lot of advantages one can have. The perpendicularity, the cylindricity, concentricity, which need different setups, are not required for 3D printing. The beauty is it derives features from CAD directly. That way, there is going to be an interplay between 3D printers and robots, and redefining the CNC form in future. Can there be retrofitted robots, retrofitted 3D printers? So, in a way, all of them, they have their own, kind of advantages and disadvantages. So, I think the whole idea is to put all advantages together. Becoming a manufacturing cocktail which is going to give everything, something like that. That's what I see. And I think I would like to stop here and push back to Mr. Jha, and we'll come back again with some more insights on this.
Thank you, Dr. Guruprasad. I think the points that you make about literally in a way, the democratization of standardization and the ability, of miniaturization of lesser lot sizes and batch sizes to cater to mass customization on the other side, and how you can potentially reimagine the future of factories rather than re-engineer today's is a key thought that I think a lot of people will take over and ponder about. So thank you so much for your comments. We'll move to Aiyappa, for your kind of opening remarks and take off from where I think you left us.
Sure. Thanks, Mr. Jha. So I'm responsible for the consulting and implementation of digital technologies for our customers from Siemens side. And Siemens, as all of you know, is the founding member of the Industry 4.0, along with the German government and a few other participants from academic as well as from the industries as well. And we are also implementing these technologies, the Industry 4.0 technologies in our factories worldwide, and also showcased in our factory in Kalwa, Mumbai. What we also do is not only practice, but we also provide these technologies for our customers, both the digital technologies as well as the automation, both the IT and the OT, to our customers, enabling the what we call as the digital enterprise. Now, when you look at this, there are, as you mentioned before, on the digital side, where you have the physical, where you have the IoT, big data, cloud, artificial intelligence coming in from the scenarios where you have the physical scenarios working, and the manufacturing which enables, which my colleague mentioned about the additive robotics, the AR and VR. Some questions came on the haptics as well, and also the scanner and CMM, where it is more on the physical side, where you are transforming the manufacturing processes, and the cyber physical side of it, where you're looking at the digital twin, closed loop manufacturing, the cyber physical systems, which virtual commissioning, changing how the future of manufacturing is going to be. So how do you see the future? You also see how you reimagine the future. So to do that, first, you should have that in your mind. And before anything you do on the physical, how do you do that in the digital? So either it is going to be your product or your plant or the connectivity. Can we have the whole systems in the software virtually created, validated, simulated, optimized? And that's basically where the digital twin comes in. So we're able to do that and also connect with the physical systems, and then that becomes a closed loop simulation as well. So you have the then you have the integration of all these end-to-end value chains, where on the one end we have the customer, the new sets of requirements which are coming inside, and then moving further into the various value chain of design, costing, supply chain, manufacturing, your production, logistics, and finally back into the customer, where how do you connect all these value chain together? And that's where the digital thread comes into play. And what you also do is, how do you enable all these aspect of it and provide these technologies where Siemens come into play? Mr. Jha.
Well, that was really short and sweet, and I appreciate the the kind of brevity with which you have put a very complex topic. So my two takes from that is that you use the digital twin for simulating any physical event, so that whatever happens in the physical world is actually simulated before in the digital world. And then you have the digital thread to cut across your entire value chain and create an episode out of disconnect events and nodes. So I think it's a very kind of a very simple and powerful way of putting a complex topic. Now, again, going into the more concrete from the abstract, I will ask Saroop to open his comments and his viewpoints, please. I think you're on mute.
Yes, thank you. Good afternoon, Mr. Jha, and good afternoon to everyone who's participating in this session and the other panelists. I am the founder of Adroitec group. Adroitec is in the emerging technologies of IIoT, robotic and automation, CAD, and 3D printing. My today's focus is on 3D printing, which is alternatively being called as additive manufacturing as well. It's a process which is a toolless manufacturing, and it is there for last 25 years. It has remained at the prototyping level. But recently, and in the last few years, it has grown rapidly because over a period of time, the material manufacturers, software developers, technology developers are coming together to enable the expansion of usage from prototype to large production. This is, I think, a repeat of what happened in 75 when giants like digital computers, which is DEC, IBM, Silicon Graphic, many of them, you may not even see them today, were making the computer, the processor, the software, the applications, everything themselves. As a result, the usage was limited. The growth of computers came up so rapidly with the democratization of the system. Number of ready-to-use applications came, and which led to significant usage of the computers. The same thing is happening today, where a lot of application developers, ready-to-use applications, technology providers, as well as the material providers are working together to make it happen. And I think the designers and the value engineers in the industry need to rethink and take advantage of the new additional process which is available. I'm not saying that the CNC will go away. I'm only saying it's an additional process available to the value engineers to explore and evaluate how they can implement it in their day-to-day process. It's so equally important to understand what does this technology offer. Medical industry like orthotics, dental, similarly industry like jewelry, are already using it for production run by personalization as well as achieving the cost efficiency. What are the four given significant advantage? Being toolless manufacturing, it gives us an advantage of making it fast and does not require multiple processes. So the factories of yesterday, which was spread over many square kilometers, can be reduced to maybe about a kilometer, 1 square kilometer. Second, no minimum order quantity. As Dr. Guruprasad said, even a single piece or a mass production, both are equally efficiently done using the 3D printing. No, it gives us a new definition of just-in-time inventory. Integration of assemblies as single components, which gives us a significant advantage of no stacking of tolerances, right? No DVM. Practically, you are able to achieve very few and thereby improve the quality. The other thing is lightweighting using lattice structure. I do hear many times in my discussions when we talk to some of the clients is that, oh, will it be strong and will it be durable? I'll just like to give an analogy, an aircraft wing. Between the foil, they have a frame. And with that, if you look at each of those components, they can be bent easily. But the frame of the wing, which is supported on the main body with few rivets, can carry a weight many times more than the wing itself. So can the lattice structure give us the strength? It actually enhances the strength rather than reduce the strength, reduces the consumption of material, reduces the time to do the printing, and thereby usefully and intelligently deployed lattice structure and taking advantage of other things can significantly improve our utilization of 3D printing and enable more efficient designs to come up. European giants as well as the American giants were taken by surprise by the Japanese because they reduced the cost and more important, they improved the fuel efficiency of their vehicle. All of us know that. And in the same manner, practically 3D printing can significantly improve the energy efficiency, and therefore every one of us need to relook at the utilization of this tool for prototyping, manufacturing, and more important, equally important, is the maintenance process, which means there is no need of inventory to be held for many years. I think it's similar in my reading, similar to the way the computer utilization exploded, the 3D printing will also get exploded with this democratization. Thank you, Mr. Jha.
Thanks a lot. I think, I've been thinking for a while. The chairman has, Tata Group, Mr. Chandrasekhar, has thrown a challenge to all of us: simplify, synergize, scale, and now speed. And I think you mentioned speed, which was fast and mono few processes, which is simplification. Just in time, you mentioned space, which is factory in a box, getting kind of factory in a box, discontinuous reduction in the amount of space which is required. You talked about the integration of processes and simplification of performance primarily through the lightweighting, and you've seen the honeycomb and the helical structures which are coming in to support far more weight than what even very large monostructures can. So I think there's a lot there and a lot of new standards, and you're also talking about a step jump in terms of reducing time to prototyping, cost of prototyping, which will, I think, fuel the next generation of innovation, because it will probably bring down the cost of, bring down the fear of failure, bring down the cost of failure, and bring down the time to failure as well, which will, support the fail fast, fail forward journey that a lot of innovation experts talk about. So thank you so much for that. And last but not the least, we go to Ankur, who just seems to have disappeared from my screen at the moment. I hope that he's around and can, put his comments forth. So, Mr. Ankur Goyal, over to you. I can't see you for some reason. Ankur,
connection or something.
I think, yeah.
lightning strikes.
National Business Forum has lost contact with international business machines. So on that, so I would request IMI to use all its, it stands for Mobile Association of Internet and Mobile Association to establish with IBM. On a more serious note, then I think we continue with this discussion. I would probably go to Aiyappa at this point, and Aiyappan, and you were talking about the technology that are shaping the manufacturing transformation. Where should the guy begin his playbook, and what in your view should they be doing? I mean, anybody listening in is saying, okay, these guys are saying all these fantastic stuff, lightweighting of structures, and Vikas was talking about performance products at faster, operations completely reimagined. Guru was talking about his factory of the future, and the holy trinity of CNC, robotics, and 3D printing. 3D printers printing robots becoming carrying 3D printing. It all looks so fantastic. But what does a poor guy? Where does a poor guy start? How did he get his money? What does he do tomorrow, which is different after he's heard all of us, kind of take his mind space? Over to you, Aiyappan.
Thanks, Sarajit. So it's a very difficult question. So while it is possibly the most important question, I would think, say there are multiple views into it. So first to look at is possibly the business view, right? Before we looking at the technology view, what is that the business is going to be? What is my business is going to be on the future? So where the business is going, maybe in the steel production or automotive or chemicals and food and beverage, variety aerospace. Where is that the business is going, and what is the where you can differentiate and also where is that the customer is going to pay for the technology or the change what is going to be done. Some of the reasons say more than what you need to do, possibly what you need not do is something which may be easier is where there is, if there is anything, you are increasing the rigidity and reducing the flexibility in your plant, in your product, in your business processes. I think that is possibly the area where needs more attention, and possibly you should be more careful in not doing it, because sometimes it is a lot more easier to look at establishing a high level of automation and in the level of increasing the productivity, increasing the OE and maintenance and so on and so forth, where the systems become more rigid, where the business is moving in a different direction. So that is one way to look at things, where how the business is doing. And the same thing can be different for different people. So for example, my colleague Vikas is there. So you have cobots, maybe 100 cobots, 200 cobots are there. Predictive maintenance on a cobot may be important, but suppose if it happens, possibly you may have few spares to replace it. The cost of doing the predictive maintenance may not be very high, in this case. I'm making an example. Maybe it is true, maybe it is not, but I'm just making an example. But for you, for example, it may be a gantry crane, or it may be a heat treatment or something else in your industry, where something of a disruption of 3 or 4 hours could cause a huge amount of loss to this company. So where you need to do what is also another way to look at, where you need to apply these technologies, and not to take these technologies and apply it all across, which sometimes, we see that. So it is important to, differentiate between the cost of the problem and what you're going to do, solve this problem, and that where is that money going to be. For example, the same predictive maintenance for a machine manufacturer. Say I am giving a high level of availability to my customer, then I can charge this customer so that I can monetize my expense. Whereas if I put it for my in-house, then that level may not be so much high. So differentiating that is important. Let's go a little more closer on the technology aspect of it. Before going any further, how do you imagine, how do you look at the future in case you identify in some area? So that is where the digital twin comes into your play. So in terms of, for example, into the product, because the product keep on changing, because the customer preferences are changing. So, and the products are becoming more connected, complex, smart, you can tell whatever, and that becomes a that becomes a scenario where there are a lot more electronics into it, like products are more mechatronics inside. So you have the electronic software, controls, pneumatic, the hydraulics, everything coming into play. How are you going to create your smart products? How do you validate this? And also how these products are going to be in the field, in the plant, as well as into the customer. And that is where the simulation comes, becomes a higher importance, where you are able to connect, create a differentiated value, and also have more margin as well as market share, where you can actually look at innovating these areas as well from a business side of it. So what I would say is, look at it from one side, from the business angle, second from the technology angle, third from the innovation aspect of it, and last, most importantly, how are you going to connect it and make a change, which is going to be digital, and it has to be individualized. As you say, you have a personalized. Customers having a personalized requirement, and every industry, every company has to have their own personalized roadmap for the industry 4.0, and that's becoming critical. You cannot do a copy paste of A to B and B to C.
Okay, so Ankur has joined us back. Thanks a lot for that. I think my main pick from that is that it's like Alice in Wonderland. What should I do is a function of where you want to and where you want to go, and it's obviously led by your business challenges and business problems. So you can't have the technology dog wagging the business tail. So you have to kind of change it. And I remember a comment that I once heard saying that if you don't concentrate on the butt, you will be in the tub. Butt standing for business viability, user lovability, and technological feasibility. It has to be all three together, because in the absence of any one of them, you will not have something that works. So yes, absolutely. So Ankur, you're back. Thanks for joining us. We were pulling your leg a bit in your absence. So over to you, Ankur, for what could potentially be the final word, because we've run out of time, and I would love to take one or two audience questions.
Sure. So sorry for disruption. I think that's one of the problem in work from home, network connectivity, and you were mentioning Sarajit before this. So that's something I faced exactly at a point where I was starting. So anyways, thanks for this opportunity, and extremely honored to be part of this.
We again lost your audio. Ankur, we can't hear you. I don't think he can hear us either. It looks like one of those Charlie Chaplin movies, it's modern times.
Am I audible to others?
Now, Ankur, you're audible, yes.
Okay. So I think most of the panel members have covered a lot of ground in terms of Industry 4.0. I would like to take at the macro view of where we are in Industry 4.0, right? So different countries are at different stage in terms of adoption, in terms of implementation. And if I look at the key drivers of Industry 4.0 or implementation of technology in manufacturing, there are three key drivers. The first one is more on the macro view in terms of macro policies or the conducive environment that government or associations create for manufacturing. The second one is more about technology availability, right? What is the ecosystem available in a country and so on. And the third one, and the most important one, is the demand. So if I look from India perspective, there are a lot of policies being pushed by government. There is recently PLI scheme, production linked incentive, and so on, right? Which is very important, and it gives a lot of boost to manufacturers to do more with less, right? There is in fact one of the platform built by CII, where all the technology partners are on a common platform. All case studies, use cases, everything is shared, so that the transaction cost for manufacturers is less. So there is a good positive environment for manufacturers to implement Industry 4.0 or factories of future. The second piece is technology readiness, right? So and I would say India is in a very strong position in terms of ecosystem. We have technology platform players, we have system integration players, and technology is quite affordable now, right? Be it AI, ML, they are no more for experimentation and research. These are proven technologies, can be implemented, has been implemented by a lot of industry leaders, including Tata Steel. So there is a technology ecosystem, and readiness also points in favor of Industry 4.0 implementation. The third piece, the key driver, is demand, right? And that is where COVID-19 comes into play. In fact, COVID-19 has amplified the need to implement technology, right? Because more and more demand is asking for being more flexible, more operationally efficient, and so on. Now, with all the three factors in favor of driving technology implementation in manufacturing, still we see that Industry 4.0 adoption in India is extremely low, right? We see only big enterprises going after it. A lot of, if I don't even count small enterprises, medium-sized enterprises, and a lot of big brands are also still in a wait and watch mode, right? I can recollect one of the reports from World Economic Forum in 2018-19. India was rated at 63rd level out of 100 countries studied in terms of Industry 4.0 readiness, right? So there is something that needs to be filled. While technology is there, players like Siemens and robots and 3D printing players are ready. Companies like IBM are ready to partner, but still the adoption is very, very low in India, right? So that's, I want to leave with this thought. There are multiple things to be done. There are multiple areas where ecosystem partners, technology companies have to work on with enterprises, with manufacturing companies, so that we can bring down the entry barrier for manufacturing enterprises. So I leave with this, and we can cover as we move on.
So
Over
what
to you,
I
Mr. Jha.
Thanks, Ankur. I think what I'll do is, you have left us to lead with the audience questions. The audience are also wondering the same thing. So there are three audience questions that I would like to take up, and I'll just read those out. One is, in unit economics of 3D printing, does it make sense versus traditional manufacturing in, say, an Indian context today? Because this maybe I would leave, maybe Vikas or someone can, Saroop can take a stab at it. There is what can be the scope of metal 3D printing? Can they replace the traditional metal manufacturing techniques? I think I'd also asked the same question in our private discussions. And the third is, from the conversation, the understanding is Industry 4.0 is about precision and efficiency. I think that's the sense that all of us have collectively given the audience. Can it enhance creativity? Because I think we all know that innovation is the delta between growth and stagnation. So whoever would like to go on questions, yeah.
Because if it's okay with you, can I answer the first one?
Sure.
Yeah, sure. Please. Go ahead.
Okay, I'll take two examples. There was a special purpose machinery manufacturer who was making special machines, and there were 400 components in a special purpose machine, out of which 250 were bought out and 150 had to be customized for every machine. Now, they had, when I went there, they had inventory of 6,000 bins, which was storing the parts. Now, and they were not able to make the changes in the second machine because they had to utilize the inventory which was already there. It's a classic example. The time taken for making each of those components was long, was going out and was getting manufactured. And the quantity was at least 10 pieces per se. The same thing could be completely avoided when the job was done using the 3D printer. So it is both the time cycle, the ability to change over and optimize, as well as the cost. All three made the user to drive toward the 3D printing. Second example, if I take it, there was a startup company which was planning to launch a Mixie. And when they were planning to launch the Mixie, they had the total cost of die, 11 dies had to be made, and they were costing them close to about 60 lakh rupees and a time frame of about 5 months, which was a very good time per se. They came to us. We, instead of making one model, we made 5 models for them, gave it to them as a service rather than as a printer, because they were more into the startup phase. When they took these 5 models, the total cost which came out was about 14 lakh rupees, and the time frame was reduced to about 1 month's time. Imagine the startup would not have been able to start the organization with 60 lakh cost, and also the time frame, the whole project would have got delayed. These are 2 simple examples, but shows how and where. So we cannot say everywhere 3D printing can be utilized, but this shows how to identify the right application to be able to use 3D printing for your application. Thank you.
So what you're saying is where lot size is important, where management of inventory is important, where the time is the main decision criteria, and of course where precision is required potentially, or where the supply chain is very long. Those are the starting points to look at.
And one more application, there was a drone manufacturer. Sorry, Vikas, you can take it over. There was another application of a drone manufacturer and an EV vehicle manufacturer. They were using very thick sheets to be able to create those landing systems. When they use the 3D printing, the wall sizes could be reduced. They could be strengthened with the ridges which were created along the body. So it gave the same strength and was able to reduce the cost significantly, and also able to improve the energy efficiency as well. So they got as many as about 500 drones completely manufactured using the 3D printing.
That's, I think, a very important point, that don't look at the 2 or 3% material wastage saving vis-a-vis milling and machining, but look at the entire amount of the 15-20% potential saving which comes from the lightweighting and the structures and the fundamental different way on the material. Also, I think you're talking about certain capabilities or abilities that you can't achieve with normal manufacturing. One of the things that I was very surprised to see is the drill bits in the oil rig, where if the drill bits break, you either maintain an inventory which is unthinkable, or you have to go all the way and fly something to Siberia to get it from shore. Whereas here the oil flows through the helical structures itself and always keeps the drill bit cool. So yeah, I can see where you're coming from. And whoever is listening in, I think these are very important points to think about, because there is large amounts of efficiency in factories that can be done in terms of spares primarily, in terms of certain new capabilities and products. Yeah, Vikas, sorry, over to you on any of the other. You want to answer the one on creativity? I find that very fascinating. We are being typeset as people who are only after flexibility and efficiency, and we don't value creativity. So you need to save the reputation of this panel.
You want me to take it, John?
Yeah, sure. Please go ahead.
Okay, I think the core question of how do you do the creativity, innovation, the improvements, that is the fundamental aspect of it, because the business is continuously changing, and one of the important enabler is the digital twin. And the digital twin is where you have the all the creativity thoughts gets in. Either you want to do that, the innovation or the changes in the product, where the product becoming more and more smarter, connected, intelligent. So how do you create these innovations into it? It could be as simple as the pulse oximeter you are looking at becoming more and more important, and or you have medical, or it may be the knee implants, that how accurately you can take it from your CT scan and create the printed the ankle the knee replacement implants, which you could manufacture, print it, machine it, and get this for overall improvement. It could be on any other industry as well. The earlier on the not more on the life sciences, but the same thing can be applied across on the plant as well. So how do you create a digital twin of a plant? What are all the parts, operations? How do you reimagine the future of manufacturing processes? how the interplay, when you are going to introduce a robot into the plant. Now, how do you do that first in the doing it physically? How many are required? Where you are going to place it? How how it is going to improve? Mr. Vikas talked about the change of production. 50% and 120%. Varying range of production. Now, before doing that on the shop floor, how are you able to do all these things digitally to look at, both at the assembly, then at the value chains, the kitting, the heat treatment, what will be the batch size at your machine shop? So how do you create the digital twin of your plant production and also possibly quality? So how do you validate, digitalize the quality to look at, the GD&Ts, where are they? Is that the right one? Can you look at the simulation like Monte Carlo to look at how my quality could be improved? The innovation could happen at all these places, but the core point again is the technologies which are able to create this digital twin to simulate, validate, and optimize, and that brings the convergence of multiple technologies, both electrical, electronic, software, controls, automation, the hydraulics, electrical, all these things together, and that is where the high level of innovation can happen. And digital twin is the platform for the innovation.
Understood. Guru wanted to make a comment.
Yeah, well, when it comes to creativity and 3D printing, Aiyappan talked about digital twin. I'm talking about the digital aspects, wherein one can think of bringing things which are unimaginable before, unmanufacturable before. So the creativity actually can be very high when you have 3D printing in your hands, because the dexterity with which it can. So there is no constraint, of any kind. We have been living with so-called 100 years of conventional manufacturing grammar, which was very limiting. And so-called the verticals, horizontals, and the planes defined as a kind of a renaissance time to today. We are all living in a box, Cartesian world being created. Probably 3D printing is going to help us go back to the time of Renaissance, wherein you can make a floral pattern, organic form can be made, and things which are assembled, like what you have in Hadapet and Belur, where chains are made in stones, right? And or you have, the other day, Saroop was telling Hathi ka andar Hathiya. Those things are made by hand, but today we can do it, not one but hundreds, replicate. Click a button, you can make it scale up, scale down, all those things, it has given tremendous dexterity to thinking, and not only just thinking and make it happen, bring it to life. And I think that's the greatest thing this technology brings, I think it's a wonderful time to be alive.
I would like to give an example on that. In Bajaj, about some time back, maybe about a decade back, we made one equipment which we call as an inkjet printing equipment. So on motorcycles, we have decals. So basically, decals are stickers which are pasted mostly on the petrol tanks, which are like for branding, for show, for things of that sort. So like Mr. Rao mentioned earlier, the interplay between robots and 3D printers. So this was an inkjet printer. So we actually did a first time in the world an inkjet printing instead of pasting the decals. So talking about which we have a patent on right now. So talking about creativity, like there is no end to creativity once you have an access to to a technology and to multiple technologies. If you're able to marry them in a way that they deliver what you are looking for, they solve a problem. And like for innovation, like we always say in Bajaj, the innovation has to be done for a purpose. It has to serve some purpose. One cannot be just innovating for the sake of innovating. So like an innovation which like we did with inkjet printing, typically a decal would cost us about 200 rupees per bike. And when we did an inkjet printing, it costed us 20 paisa. So that is the amount of saving that we get on that. So, and like Mr. Rao said, the creativity becomes very high when you have an option of 3D printing, which I absolutely agree to, because we have been doing a lot of fixtures, lightweighting them either for tackles, for material handling, or for having kit bins for handling components. And earlier we had an issue like it's so difficult to manufacture. But now, like putting it on the paper, knowing that I can 3D print it, there is no end to it depends upon your creativity, how efficient, how lightweight, and how useful you can make that product.
So, Vikas, just a follow-up question, where creativity and collaboration intersects with technology is what we call cobots today. And Bajaj, your company has been a leader in that space. So, would you guys like to, spell out for the audience some of the things that they can start thinking about or doing in terms of the whole cobot revolution?
Thanks for the question. Actually, Bajaj Auto has been the earliest adapters of cobots in India. It was back down in 2007, 2008 that we first explored cobots. And there's this company called Universal Robots from Denmark. That's from where we bought our first Kobo. We kind of experimented with it for about 3 months, and we found that being a collaborative roto, being very compact, lightweight, it has tremendous use, which it can serve a purpose in the assembly lines, which are very space constrained and have almost about 50 to 60% of the entire labor content of a typical automotive company. But of course, the costs were inhibitive. So we actually entered into an agreement with a technical know-how agreement with Universal Robots, by virtue of which we started manufacturing or assembling the entire cobot in-house. We were the first company in India to, of course, do that. So, which gave us about a cost saving of about 40% over the market price. Over a period of time, we have installed, I think, more than 100, 150 cobots, 100, both within Bajaj Auto and across the supply chain. So, like I mentioned, the specific example of assembly lines, where it really serves a very useful purpose. We have done it for specialized decal applications, where the decals are applied with the cobots. For sealant applications, we've used them for vision inspection systems. We've even used them in fabrication lines. Once the frame is fabricated, then within the fabrication line, there's a man standing next to the cobot, and the cobot is inspecting the entire frame for inspection. We use it for bolt tightening applications. So, of course, like a cobot has been a very useful tool which we have deployed in Bajaj. And I think the future of the cobot would mainly lie in assembly areas more than anything else. That is my personal take on it.
Thanks. We are horribly out of time, but Ankur, we didn't have a share of voice. So before we go, what is the 3 quick things that people will have to look out for, which could stop them potentially from reaching the full potential of these technologies, 3D printing, robotics, CNC, cobots in their respective companies?
So I think the very first one is that rather than keeping technology at the center, we need to keep business imperatives at the center, right? Some of the questions that I saw, what can Industry 4.0 give you? That should not be that should not be the way forward. The way forward should be that this is my problem. Industry 4.0 is one tool. 3D printing is one tool, right? Like we had lean, continuous improvement processes, and so on. So it's very important to build our blueprint, roadmaps, and whatnot around business imperatives, around people, and use technology to our advantage. That is number one. Number two is we see that a lot of enterprises in India who get into technology, they end up in pilot purgatory, right? They're not able to scale up after a certain level and so on. That happens because probably the technology is not scalable. Probably a lot of companies don't understand the right starting point, and that starting point is different for all the companies, right? So that has to be thought through before technology management. People are key to this transformation. We need to have champions inside enterprises. We need to have people who understand technology. It has to be done in a co-creation mode with your partners. So these are the three key takeaways that I would like to
Use
suggest,
case,
Sarajit.
scale, and capability. Those are the three most important things. Use
Yeah.
cases, select the right ones which business needs, prioritize them. Make sure you don't become a pilot purgatory by doing too many experiments, have a route to scale, and finally you need people and capability and a culture to get it done. So that's, I think, a fantastic summary. I thank everyone who's watching in, and of course my fantastic panelists. Thank you so much. You've been a very wonderful sport, keeping largely to time and keeping the comments precise and to point. And I hand it back over to the host. Thank you so much, everyone listening in, and stay safe. Be very compassionate and kind. We as humanity need it. And I wish you all the very best. Thank you so much.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, speakers, for this panel, for an amazing discussion. Thank you to our moderator, Mr. Jha, for keeping the discussion relevant, interesting, and so exciting. A huge thank you also goes to all the speakers and supporters who were there with us in these 2 days of summit and made it a super successful first edition. Thank you to our partners Accenture, Automation Anywhere, Route Mobile, Tata Teleservices, and PwC. Dear audience, hope you enjoyed it and it was insightful for all of you. We wish all of you to stay safe and healthy and please help each other in these difficult times. Stay tuned for various events lined up for you, information of which you may get from IAMAI website. Goodbye till we are back with the next edition next year. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.